What's up, physics fans? This is Physics 11. This is a mastery question of the projectile. It's also the last page of the projectile package, which is page 14. This is question 27. So you practice this until you cannot get it wrong. So a ball is thrown at a velocity of 28 meters per second, 37 degrees above the horizontal, from the top of a cliff that is 35 meters in height. So those are the three numbers that are given, and you have to determine the horizontal velocity initial, the initial vertical velocity, the final vertical velocity, the change in vertical velocity, the time, how far away from the base it lands, and what's the total velocity. We both need the magnitude and the direction. So let's just start rocking on this. This is the opposite. So, you know, sine, let's just go, whoops, here we go. Sine is equal to the opposite over the hypotenuse. So that gives us that the hypotenuse, whoops, it's not what we want. We want the opposite. That's what we're trying to solve for, the opposite. Opposite is equal to the hypotenuse times the sine. So this is going to always be, because it's always the opposite, this is going to be 28 times the sine of 37. It'll always be the hypotenuse times the sine of that. And consequently, since this is the cosine, so katoa, right? And that's going to be the cosine is equal to the adjacent over the hypotenuse. So this is always going to be that the hypotenuse times the cosine will be the adjacent. And that's what we're trying to solve for. So the adjacent is always going to be 28 times the cosine of 37. So there's just some theory there. Here we go. Let's just plug them into the calculator as we go here. 28 sine 37 and 28 cosine 37. So the sine is, let's do it in black here, this is upward, and that's going to be 22.36. So initial velocity vertically is 22.36 up. And this is going to be, oh, no, I got that wrong. The sine is 16. Let's not do this. 16.85, see? So quick. And if you do it wrong, you're doing a different question than the one I gave you. You're still probably doing everything right, but not, okay, it's not the one that we wanted. So this is, the sine is 16.85 and 22.36. And of course, if this is 37, there's more horizontally than vertically. This has got to be bigger than that. That's right. So this is 16.85 up, and this is horizontal 22.36. Why did I write it so big? Because the initial and final horizontally doesn't change, so that it means it's zero acceleration. But this acceleration is down at 9.8. So it's going down, accelerating that way, initially going up. And it's going down 35. So it's going down 35. Okay, so the first thing that we have to calculate is the final vertical velocity. So we're trying to solve for this. Without time, we use VF squared is equal to VI squared plus 2AD. So this is going to be the 16.85 squared plus 2 times A, 9.8, and D, which is 35. I've been leaving big spaces in my brackets because I'm going to teach something here quickly. This is up, and these two are down. In this mastery question, which is lower, it lands lower. That means that's down. That's down because those are in the same direction. If we say negative is down, a negative times a negative, this term will be positive. But if I said this was positive, and a positive times a positive, that term is still positive. So no matter which direction I choose is negative and positive, this term is always positive as long as we're going down. And this is squared. So it don't matter if it's negative or positive. If I square it, I get a positive. So this is always going to be a positive plus a positive as long as it's going down. If it's going up onto a ledge, here's the hill, and it's firing it up onto the hill, then this term will be negative because this will be up, that'll be down. So that's the only difference every single time. And someone says, well, I chose positive to be up. Doesn't matter. You're going to get the same number here. You like my voice? That's good. I'm singing away. Here we go. So take the square root of that squared. So, well, let's just take that number squared. Let's do this long way. Here we go. Take that number, square it, add 2 times 9.8 times 35. And this is going to be 969.95. So VF is going to equal square root 31.14. Now, is that a positive or negative? It doesn't matter. The positive and negative just indicates the direction, and we know the direction is down. So this is going to be, let's go into red here, 31.14 down. Then what is the change in velocity? Sorry, that was C. That's A, and that's B. So now D, the change. So we want to know, if we're just going to take a look at these two, that number and that number, how much of a change is it between that? Well, one is up and one is down, and we want to subtract them, but since they're opposite, we're actually going to add them. We want to find the difference between them. So you take this number, and if you didn't get that, let's just go the long way. Here we go. The change in velocity is VF minus VI, but VF is down, and VI is up. So we have to go VF. Now we're going to go plus a negative VI down, up. But a negative VI up will be VF plus VI. Since we're subtracting them and they're in opposite direction, a negative VI up will be VI down. So we just actually have to add them. So let's take VF, the number that we just had, and we have to add the 16.85. And that'll be the change in velocity. So the change in velocity is going to be 47.9948. Write a lot of numbers down there. Not as necessary, but so yeah, 44.99. Okay, and then the next step is to find out the time, because that's the change in velocity. Well, the time is the change in velocity over the acceleration, because that comes from the formula. Acceleration is the change in velocity over time. So we just rearrange that to get the time. We get this. So we take the number that's on the screen, 47.9948, and divide that by 9.8. And we get the acceleration. No, we get the time. Divide this by 9.8. And we get the time of flight from launch to landing, 4.8974 seconds. Time in seconds. Here we go. There's the pathway that we did these two first, and then that's the pathway of our work. Kind of separating it out so that we can follow through the work afterwards. The range, which is the horizontal distance, is this number here. And that will be the horizontal distance. And that is going to be velocity times time, because it's constant velocity. That's the only time we can use that formula in this whole question. There it is. and that's just going to be the velocity, which is number 1, times the time, which is e. So it's going to, both these numbers are on the calculator, don't have to punch them in. So we take the time and multiply it by the velocity, which was the 22. Oh, there it is, the 22. And we get the range to be 109.51. 515, I guess it's a 5.2 meters. Okay, and last but not least is the final total velocity. We could have done this before, quite a bit before, because we got the final velocity here. So horizontally, it's still going and always going at 22.36, but it lands over here at 31.14. It's going down. So draw the horizontal first and then the vertical. Why? Because then the angle is going to be the angle we want, which is below the horizontal. If you drew the vertical first and then drew the horizontal, you would be getting this angle, and that's away from the vertical. You can do that, but the way we want it is below the horizontal. So Pythagoras says we can get this hypotenuse by that squared plus that squared all square rooted. And to get that angle, we'll talk about it in a second. Let's do that hypotenuse first. Is a squared plus b squared, and that is basically the velocity. These are velocities, these are final velocities. This is the component horizontally, that's the component vertically. So this is going to be the velocity, is going to be the square root of 22.36 squared plus 31.14 squared. Okay, so it's going to be the square root of the 31, which is ways back that we calculated that one right there, squared, plus the 22. That's going to be one of the first things we calculated. Here it is. That number squared. So we get the vector final velocity is 38.34 meters per second. Okay, yay, got that. Now we need that angle. We need this angle. So if we have the opposite and the adjacent, then we use the tan. The tan is going to be the opposite over adjacent. But we want that angle. So we have to go that the angle is going to be the inverse tan. Okay, we want to get the inverse tan to get the angle, so we have to inverse tan of opposite over adjacent. So theta is going to be the inverse tan of opposite, 31.14, over the adjacent, 22.36. Inverse tan of the same two numbers we just did, but they're up here. That number divided by the 23. Sorry. 22.36, yeah. Close the bracket, boom. There's my angle. The angle is 54.32 degrees. But how do we write that together? There's my first part, my magnitude, there's my direction. and that's going to be below the horizontal. There's my horizontal, and it's going to be below it. So the vector velocity is 38.34 meters per second, and the angle is 54.32 degrees B below the horizontal. And that's the vector final velocity. The vector initial velocity is 28 meters per second, 37 degrees above the horizontal. And the vector final velocity is 38.34 meters per second, 54.32 degrees below the horizontal. That was well laid out, spelled out, lots of different steps, and 15-minute video, but that was explaining every single step. So hopefully I'm going to do it again, maybe put a bit of different numbers into it, and we'll see how fast we can go through it without explaining it all. Anyhow, thank you very much for watching. Thank you very much for learning. Take care. Subscribe. Click the like button. They're down there. And comment. Please leave a comment. I love hearing those comments. Thank you. Bye-bye.